Chapter 4, Day 1, we are going to explore relations and functions. We're going to determine what a relation is and a function. We're also going to talk about discrete or continuous. So, here's some vocabulary. A relation is a relationship between two sets of data. So, it's often represented by a table, a set of ordered pairs, or by a graph. But basically, a relation right here is any set of ordered pairs. A function is specific set of ordered pairs. And we'll get to that in a little bit. So, we can represent it as a set of ordered pairs like this. This is a set of ordered pairs. Or we can represent it by a graph. And these are some examples of graphs. This is a table. And we won't do much of this necessarily, but this is a map. So a map is really the same as like ordered pairs. These are like your X's and these are like your Y's. So like, let me try again. These are X's, these are Y's. So this 7X as an X goes with 0. So that would be the ordered pair 7, 0. But the 7 also has an arrow going to -1, so you'd also have an ordered pair 7, -1. It's kind of like a T-table also, okay? So that's how we represent relations and functions a lot of times. So let's look at the difference between a relation, which is any set of ordered pairs, but there is a relationship between the two sets of data. Like when you look at this graph, it's age and weight. So you have your weight and your age, and depending how old you are, your weight is going to obviously increase from when you're a baby to, when you're 12, but then it kind of stables off at some point in time. Okay, so now let's look at what a function is. So a function is a special type of relation. So it's a special set of ordered pairs such that for each X, there's exactly one Y value. And the thing that we kind of look for is the X's don't repeat. That's what you're going to be looking for, especially when you look at ordered pairs or a T-table. So if you look at this first example, okay, you have your X value of -2 has one ordered pair or one value 14. X goes with 0, 4, and 5. So if you look at this, the X's don't repeat. That's what we're talking about. If you look at this map, however, and you also look at this map, these are all examples of function. The 6 only has one arrow going from it, so the 6 goes with -1. But in the last example, there was two arrows coming off of the same number, and so that would not be a function. So functions, each X value can only have one exact Y value with it. So we kind of ask ourselves this question. When X is blank, Y equals blank, and here we can only have one answer. Or one value. Okay? So another way we can look at that is on a graph. When X is -2, Y is 0. When X is 0, Y is -4. So that's what I'm talking about. When X is Y equals, there can only be one answer that you say for Y. And one thing we look at with a graph is something called the vertical line test. Okay, if you're looking at a graph, if your X has only one Y value associated with it, it will pass the vertical line test. But if you ended up having 2 points on a vertical line, it would not be a function. All right, so let's practice some problems. Are the following relations also functions? They're all relations, okay? All of them are relations because they're sets of ordered pairs. We want to know which ones are also functions. So let's take a look. We look at the values here for letter A. So if you look at the x's here, do you see any repeated values? No. So no repeats. So yes, this is a function. Okay, so now you try letter B. Okay, so you try letter B, pause the video, and then put it back, start the video again and see if you got it right. So for question B, again, if you look at the x's, notice you have 3 2's. So you have x's repeated. So x's repeat. So no, not a function. So that's what we're looking at. That one is not a function. Okay, the first one was. This one was. So what about letter C? Now we don't have it in a T table, but we still have a set of ordered pairs. So look at your x's. Look at your x's. 3, -2, 9, 4. Do they repeat? No, they don't repeat, so no repeats. So it's a function. Okay, your turn. You try letter D. Well, if you did it correctly, it is not a function. Because we can see we have x's repeating again. So here's what I'm talking about. In this example, if you say when x is -2, y is, you would say 2. But you could also say when x is -2, y is -2. So you have 2 different answers for that y value. When x is -2, y is 2 or -2. That's what we're talking about, where each x value has only exactly one y value. All right, so we decided A was a function and B was not. So what can we tell about their graphs? Well, this is the graph for A. This is the graph for B. This is what I was talking about with that vertical line test. If you draw vertical lines here, each x value has only one y value, or you only have one ordered pair on every vertical line. But if you look at this one, that was not a function, notice that when x is 2, y has 3 different values. When x is 2, y is -1 for this ordered pair. And when x is 2, for this one, y is 1 for this ordered pair. And for this ordered pair, when x is 2, y is 3. So again, you have your x values. The x value of 2 has 3 different y values, not one exact. So that's what I'm trying to talk about and explain to you. And it does not pass the vertical line test. So how do you determine if a relation is a function? Well, from a data table or ordered pairs, okay, the x values or input values do not repeat. do not repeat. So again, we look at this one. We look at our x's. This is a function. So this is a function. Let's look at this one. Look at your x's. Oh, this one is not. And we already went through some of these again, but you try the other t-table here. You try this last one. And this one is. And you can see those are worked out there, but let's move on. So let's go to the mapping, okay? For a map, what you're looking for is only one arrow comes from each value in the first set. So only one arrow comes from each value in the first set. So here's what we can look at, okay? This one is because each x value has only one arrow coming from it. But notice on the second one, the 7, and we looked at that earlier, has 2 arrows coming off of the same number, and that's how we know it's not. And finally, we can tell whether it's a function from a graph, again by doing that vertical line test, and 2 or more points may not line up vertically for the graph to be a function. Another way to look at it is 2 points can't be on the same vertical line. So can you figure out whether these are or not functions? Well, this one is. It passes the vertical line test. Wherever I would draw a vertical line, I would only touch my graph once. But over here, this one is not. Because if we draw this vertical line, we can see that it hits my graph in 2 places. It hits my graph right here and right here. So that one is not a function. All right, so we talked a lot about function versus relation and how to tell whether a relation is a function. A function is a special relation, okay? So now let's look at discrete versus continuous. So discrete functions or relations, either one, a function or a relation can be discrete or continuous, are separate points. It's a dotted graph and it's things that you can count. So it's countable. So notice these are examples of discrete. You can see there are separate individual dots here. And you can look at these ordered pairs. You'd have 3 separate ordered pairs. Now that's different from continuous, where continuous you have connected points, making either a line or a curve. And now we can't really count. There's an infinite number of points, and even between these points, there's an infinite number of more points on this graph. So you have an infinite number of points on the graph, so it's not countable, but instead we could measure it. It's measurable, we say. So when you graphed lines last year in slope-intercept form, y equals mx plus b, okay, you plugged in values of a t-table, okay, and you plugged in values and you graphed a line. That's measurable, that's continuous. So, discrete, again, why is this a function? First of all, this is a discrete function because these are separate individual points, okay? Why is it discrete? Separate points I can count. For both of these, I can count 1, 2, 3. I can count my points, 1, 2, 3. Why is it a function? Well, because no x's repeat. Notice you have -2, 0, and 4. No x's repeat. And in the second example, it passes the vertical line test. We abbreviate VLT. Okay? So let's look at the second example. This is discrete because if you look at one pizza, let's say it costs $5. 2 pizzas, $10. 3 pizzas, for every X value pizzas, I only have one exact Y value answer. Okay? And I can count. I can't have any information in between that I could measure because I can't buy. Another way to look at this is, can you purchase 1.1 pizzas? No. They are not going to allow you to do that. So that's how you know it is countable and discrete. Okay? And so on a graph, again, you would graph 1, 5, 2, 10, etc. So why is this a function? Again, because you have separate points. Oh, that's why it's discrete. Separate points. And you can't buy 1.1 pizzas. So it's countable, not measurable. Why is it a function? It's a function because each X value only has one exact Y value or cost. So each X value of number of pizzas only has one exact cost. Here's some examples of continuous. Okay? First of all, why is this a function? Because it passes the vertical line test. Why is it discrete? Well, it's not discrete. It's continuous. That must be a mistake, a typo. So it's a continuous function because it's connected points on your graph. I think this is supposed to say continuous as well. So why is this a function? Your height as you grow from a baby to an adult. Okay, so here's your height and here's your age. So when you're a young child, your height is pretty low. Okay, and then it keeps going like sort of up, and you actually grow pretty fast, and then you kind of level off, and then you grow again, and so on. But if you think about it, your height keeps growing in between each year. So if you're going by years, if this is 1 year, 2 years, 3 years, you don't just jump up from age 2 to 3, you don't just jump up like a half a foot. You grow all those other increments in between, okay? So from 2 to 3, you don't just like jump up that hard, or that far. You have to grow all those other increments in between, and that's why it's measurable rather than counting it. So that's why it's continuous, because you keep growing in between the years. So you can't count, you have to measure. And this is a function because for each age, which is your X value, there is only one height. All right, so that is the end of our day 1. That's a lot of stuff introducing Chapter 4 functions, but this is important stuff that we will continue to talk about throughout the year.